All right, guys, we're going to start the next section here. So we're going to move into Chapter 2, Section 4, finding maximums and minimums of polynomial functions. Now, we're not going to cover the whole section here. We're only going to cover half the section, being that the first half is quadratic functions, and that's where we're going to spend most of our time at here. We'd like to look at more quadratics. Now, we're going to go back a little bit into Chapter 1, Section 7, and talk about how we found max and min values of quadratic equations and functions. So how we did that, if you remember, we looked at the middle point of a quadratic being the vertex. And the vertex either gave you a maximum or a minimum. In our case here, we're trying to, in our problem here, you can see that I've already typed it out. Our problem that we're going to be looking at, our problems, are going to be maximizing the greatest possible thing. And so in this case, we're going to look at finding the greatest area. Now, if we talk about a minimum area, you would use the same idea, but it would be more direct in asking for max or min. So one thing you have to remember, and you can write this down too if you don't remember, but in order to find the vertex, it's x equal to negative b over 2a. And now when you have the x equals negative b over 2a, that gives you your x value of your vertex. And again, if you have a quadratic, this would be your vertex. That's your maximum value, right? Or if we're going to find our minimum value, then the vertex would be right here in the middle, and then that would also be your vertex, and that would be your minimum value. And so we're going to be using that idea to solve different types of problems. So you can see in example 1, it says a rectangular dog pen is constructed using a barn wall as one side and 60 meters of fencing for the other 3 sides. Find the dimensions of the pen that give the greatest area. So I'll give you time to go ahead and write that down. Okay, so if we're looking at the first thing that I'm going to do here, and this is not a requirement, but it's a good idea, we're going to draw this picture because let's try to put it into perspective what it's asking. So we're gonna build this dog pen using a barn wall as a side. So I'm going to say that I have this barn. Of course, I'm going to make it red. It's very cliche here with the red barn. Okay, so here's my red barn. All right, that's all this is my barn in here, right? Okay, so I have this barn wall that I'm going to use, and I'm going to create this fence that somehow maybe uses the whole thing or not. But I'm going to draw my pen to look something like this. So this is my pen here. This is my dog pen. And I want to be able to use all of the fencing if possible. So I'm trying to maximize my area with what I have. And so a lot of people say, oh, well, let's just make it a 10 by 10 or a 5 by 5 or something into that matter. But there's a lot of math that can go into it, and then you can find out exactly what maximizes your area. So what we're going to do is one thing that we know is that we have 2 sides that are going to be the exact same size. And so we're going to just put these as x. So we know those are going to be the same because we're going to make some kind of rectangular dog pen like it says, because it says right here in the directions that we're going to make a rectangular dog pen. And so we know that it's going to be rectangular. So we know 2 sides are going to be the same. The other 2 sides are also going to be the same. But the difference is that we're using the barn side for one of those sides, right? So the idea is that we probably will be looking at maximizing that length. So what we're going to do is we look at the dog pen and we say, well, if we're going to have x and x lengths, I mean, we have 60 meters in total, then that means what we have left is we have 60 minus our 2x, because we're going to use x over here and x over here. right? So that gives us 2x. So if we have 60 total, we're going to subtract these two pieces, and then that's going to give us our maximum space. So think about how you take an area of a rectangle. Take an area of a rectangle, base times height, or length times width, however you want to say. So we're going to say that our area, with respect to our x value, is length times width. So we're going to say x times 60 minus 2x. And so this looks like it's just factored form because it is, but now let's get it into like a quadratic form and standard form as best as possible. So we distribute the x. I'm going to rearrange it just a little bit. Actually, I'll go ahead and I don't want to skip the step, I guess. I don't want to give the extra stuff. We'll say 60 times x minus 2x squared. And so now I'm going to rearrange it. And it looks like that. And so what does that give me? That gives me quadratic form and actually standard form. And so why is it standard form? It doesn't look like there's a c value. Well, there is. It's just out here it's plus 0. There is a 0 out here. So now we can go through and label a is -2, b is 60, and then c is 0. But we don't need all that extra, because to find the vertex, if you remember, it's x equal to -b over 2a. And so our b, in this case, is 60. And then it's 2 times -2, which gives us 60 over -4. Gives a positive now, and that gives us 15. So what does that mean? What that means is that our x value, to maximize our area, our x value in our dimensions must be 15. So when we look at this and we say, okay, great, so we need to find the dimensions, what we're going to do is we're going to substitute this piece into here and then also into here, and that'll give us our dimensions, this by this. So the first dimension is quite easy to see, it's just x is 15. The second dimension, we're going to say it's 60 minus 2 times 15, which is 60 minus 30, and that gives us 30. So it asks, find the dimensions of the pen that give the greatest area. In our case, we're going to say it's a 15 meter by 30 meter pen. Or you could put an X there for by, it doesn't matter. Now, how could we take this even further? We would say, what is the area, what's the greatest area we can come up with? If that does get asked, then you can just say, well, a of x equal to, and you just do 15 times 30, okay? So it'd be 15 times 30. You're basically skipping the step in that we're plugging in. I should be a little bit more specific here. I could say 15 because we're just substituting this into right here. And then 15 times 30 is 450. This is 450 meters squared. Okay, so that's what we're going to focus on today. We're just going to focus on finding the quadratic, using the quadratic formula, using quadratics, using the vertex to find, in our case, is going to be our maximum, and that's where we're going to go from. Okay.